In our last lesson, we talked about Boyle's law, and today we're going to go on and we're going to talk about Charles' law. Now, Charles' law tells us the relationship between the volume and the temperature of a gas in a sealed container. Before we go ahead and talk too much about Charles' law, first let's talk a little bit about temperature, because we need to know a couple of things about the temperature. So today we're going to talk about Charles' law, and our target is to be able to use Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law to solve problems involving temperature, pressure, and volume. So let's talk a little bit about temperature, and then we'll go into Charles' law. A couple of things to say about temperature here. In your everyday life, you're probably used to measuring temperatures in Fahrenheit, and in science, we don't use Fahrenheit. We don't use it at all in science. Usually when we measure a temperature, it'll be in Celsius. If you look at our lab thermometers here, they're all in Celsius. We don't have anything in Fahrenheit, right? But there's also a third temperature scale, a temperature scale that we often and frequently and will use in science, and that's called Kelvins. Kelvins are a little bit different than Fahrenheit and Celsius, whereas Fahrenheit and Celsius, you call it a degree, right? Degrees Fahrenheit or degrees Celsius. You don't do that for kelvins. You don't say degrees Kelvin. You just say kelvins, right? So if it's 100 kelvins, then it's 100 kelvins. You don't say 100 degrees kelvins. A couple other things we should know about the Kelvin scale. 0 on the Kelvin scale is what's called absolute zero. It's the absolute lowest possible temperature. In Celsius, it's negative 273 degrees Celsius. In Fahrenheit, it's negative 460 degrees Fahrenheit. The absolute coldest possible temperature, called absolute zero, on the Kelvin scale is 0 kelvins. So since that is the absolute lowest and coldest possible temperature, you cannot have a negative temperature in kelvins, right? If you see a temperature that says negative 10 kelvins, ain't right, ain't possible, can't be. A temperature in Kelvin has to be a positive number. It can't be a negative, because 0 is the lowest possible temperature. Okay, a couple other things here. We are at some point going to have to convert between Celsius temperatures and Kelvin temperatures. We could also throw Fahrenheit into there, but we're not going to do it. It's a little bit more complex, but not too much. Converting between Kelvin and Celsius is extremely easy. Extremely easy, because a Kelvin is the same size as a degree Celsius. So 0 kelvins is negative 273 degrees Celsius. So the two scales are just different by 273. So if you're given a temperature that's in Celsius, to figure out kelvins, all you have to do is subtract 273. If you have a temperature that's in kelvins and you want degrees Celsius, all you have to do is add 273. So there's the key number there for going between Celsius and Kelvin, 273. Let's go ahead and let's do a couple examples of changing between Kelvin and Celsius temperatures, and then we'll go on and we'll talk about Charles' law. So here we have some temperatures that are in degrees Celsius, and it's asking us to change them into kelvins. So let's take a look at that, and then afterwards there are a couple there that give us temperatures that are in kelvins and asks us to convert them into degrees Celsius. So remember, to change between Kelvin and Celsius is just a matter of 273. So here are my temperatures that are in Celsius. To change them to Kelvin, I'm going to add 273. And then we can use our calculator and figure out what those are. So I got 50 degrees Celsius plus 273 is 323 kelvins. Easy enough. The other one here, we have negative 75 degrees Celsius. Add 273. And I get 198 kelvins. Okay. Let's see these ones down here. They give us temperatures in kelvins, and they want us to change them to degrees Celsius. So instead of adding 273, we are going to subtract 273. Okay, so 300 minus 273 should give us 27, and that'll be degrees Celsius. And 375 minus 273 is going to give us 102 degrees Celsius. So there's a little bit of converting between temperatures. We're going to need to be able to do that as we use Charles' law. So let's go ahead and talk a little bit about Charles' law. Charles' law is named after this handsome gentleman here, whose name was, he was a Frenchman by the name of Jacques Charles. I know my French is great. Okay, Mr. Charles there is who Charles' law is named after. And Charles' law tells us about the relationship between the volume and the temperature of a gas in a sealed container. Okay, think about, I'm sure everybody's probably seen a video of this or a demonstration of this. Think about a balloon that has some air in it. And we're going to take that balloon and we're going to make it very, very cold, right? I'm going to put a link to a video, maybe right there or right there. I don't know where YouTube's going to put it, but you'll be able to see this guy. He's going to take some balloon animals and he's going to put them in liquid. I think it's liquid nitrogen he uses. Very, very cold. What's going to happen to the volume of the balloon? Will the balloon shrink or will it get bigger when it gets very, very cold? Well, if you said it's going to shrink, you're absolutely right. So when the temperature goes down, the volume also goes down. What's going to happen if you make it very hot? Probably at some point you've left something like, I don't know, a bag of chips or something that's got air in it in the car on a hot summer day. And what happens to it? Maybe it gets all puffy, right? Why does that happen? Because when the temperature of the gas goes up, its volume also goes up, right? So temperature and volume, they'll go up together or they'll go down together, right? And this is Charles' law. Usually we write it like this. It says V1 over T1 equals V2 over T2. And the V's, of course, are for volume. The T's, of course, are for temperature. And the ones and the twos, just like last time with Boyle's law, they just refer to, this is the state of the gas before it changed or the state of the gas after it changed. Right. So V1 over T1 equals V2 over T2, Charles' law. Let's go ahead and let's take a look at some problems involving Charles' law and see if we can't solve them. Okay, here is a problem for us to take a look at. It says on hot days, you may notice that potato chip bags seem to inflate even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius, and I leave it in my car at a temperature of 60 degrees Celsius, what will the new volume of the bag be? Okay, well, a couple of things here. First, just like with the last one, I'm going to go through and I'm going to identify what each one of the variables is, what all the numbers in the problem are, and what they asked me to find. And then I'm going to put the numbers into the equation and solve for the thing that I don't know. Okay, now here's the thing. When we're working with the temperature, we can't work with Celsius, okay? We're going to work with kelvins. So all these numbers that they give me in degrees Celsius, I'm going to immediately convert them to kelvins and work with kelvins. Okay, so let's go through and let's take a look. The first number I see in the problem, it says 250 milliliters. Now, milliliters tells me that's a volume. So this is the volume beforehand. It's V1. Okay. The next number I see, it says 19 degrees Celsius. That's a temperature. And this is the temperature before the gas changed. So that is T1. T1 is 19 degrees Celsius. Now, like I just said, we're not going to work in Celsius. We want to work in Kelvin. So just right away, I'm going to change that into kelvins. And I know I can go from Celsius to kelvins by adding 273. So that'll be 292 kelvins. Okay. Let's see, the next number I see there is another temperature. So it asked me to find the other volume. I'm going to put V2 equals a little question mark there because I don't know what that is. And then T2, temperature 2, it told me it was 60 degrees Celsius. And just like the other temperature, I'm going to immediately change it into kelvins. And that is 333 kelvins. Okay, now we will take these numbers and we will put them into Charles' law and solve for the one that we don't know. Okay, let's see, let's come over here. So volume 1 was 250. Temperature 1 was 292. Okay. Volume 2, we don't know. I'm just going to write V2. Okay. And then temperature 2 is 333. Okay. Now, a lot of times students get lost at this point and they say, how do I solve this equation that's got fractions and things on the top and on the bottom? Okay, we're going to have to use algebra to solve it, but we can easily solve it. You probably learned how to do this in algebra class. What we're going to do is we're going to cross multiply. Okay, so I'm going to take the denominator times the numerator equals the denominator times the numerator. So let me go this way first. I got 292 times V2, which is 292 times V2. Okay, and then I'm going to go to the other way. I have 333 times 250. And I'm going to grab my calculator and do 333 times 250. And there I get 83,250. Okay, so I multiplied this way and I multiplied that way. I cross multiplied. Now it's pretty easy to see, to solve this here equation, I'm going to want to divide by that 292. So I'll do 83,250 divided by 292. And I get about 285. I'm rounding it off there. Okay. Now, this was a volume. Okay, and so the unit we're going to put on that should have the same units as the other volume. The other volume was in milliliters. So this is 285 milliliters. Fairly simple there, huh? Let's take a look at another example. Okay, this other example here, it says the temperature inside my refrigerator is 4 degrees Celsius. If I place a balloon in my fridge that initially had a temperature of 22 degrees Celsius and a volume of 0.5 liters, what will be the volume of the balloon once it's fully cooled? Okay, so very similar problem here. The first number I see is a temperature. It says 4 degrees Celsius. So that's actually going to be, think about what's happening to the balloon. It's starting out warm, and then we're putting it in the refrigerator to cool off. So that 4 degrees Celsius is actually temperature 2. It's the temperature after it changed. Let's see, the volume 1, if you read carefully into there, was 0.5 liters. This was its volume when it was first put into the refrigerator, and its temperature at that time was 22 degrees Celsius. Now I see Celsius right away. I'm going to change that to kelvins. I'm going to add 273 to change it to kelvins. And that'll give me 295 kelvins. Okay. Now volume 2, they didn't tell me. That's what we're looking for there. And then temperature 2, like we just mentioned, is that 4 degrees Celsius. And I see degrees Celsius, and right away I say, oh, I got to change that to kelvins. So let me add 273. So that makes 277 kelvins. Okay, let's go over here and we'll put those numbers into Charles' law. So over here, volume 1 is 0.5. Temperature 1 is 295. Volume 2, we don't know. And temperature 2 is 277. Okay, we're going to solve this one just like we solved the last one. So first what I'm going to do is I'm going to cross multiply. I will multiply this way and this way. Okay. Let's see, 295 times V2 is 295 times V2. And then 277 times 0.5 is 138.5. 138.5. Okay. And then I hope we can see that to solve this equation, we just have to divide by 295. So I'm going to divide by 295. So here I have V2. And here I'm going to use my calculator and divide by 295. And I get, let's see, I'm going to round this off to 0.47. Okay. Now that is a volume, and so it should have the same units as the other volume. The other volume was in liters. So this one should be 0.47 liters. So you can see putting a balloon in your refrigerator takes it from 0.5 liters to 0.47 liters. It's not a big difference, right? But it's not a hard problem. So there we go. There's our other example. All right, so in this lesson, we have learned a little bit about the temperature, how to change between kelvins and degrees Celsius, and we learned about Charles' law. We learned how to solve some problems involving volume and temperature with Charles' law. Next time, we'll go ahead and we'll talk about the relationship between pressure and temperature in Gay-Lussac's law. So until then, take it easy.